Important note: in continuation of center of mass, we'll see some important notes here. The first point is position of center of mass of a system is independent of the choice of the coordinate system. That means whatever coordinate system you will select, whether it is polar or the Cartesian coordinate system, but the position of center of mass will be always independent of this choice of the coordinate system. Second point, the position of center of mass dependent on the shape and size of the body and the distribution of its mass. Third point, center of mass lie within or outside the material of the body. Means it is not compulsory that center of mass always lie within the body. Sometimes it lie outside the body. In case of ring, we'll see that if equal mass distribution is there, in such case, in case of ring, we'll find the center of mass at the center of the circular coil, and where no masses will be there, that means outside the body or outside the material, the center of mass you will find. Fourth point, in symmetrical bodies with uniform distribution of mass, the center of mass coincides with the geometrical center or the center of symmetrical body. This point already I have explained to you. Whenever you will take a symmetrical body, that means well defined geometrical figure, rigid body, so in such case the center of mass always coincide with the geometrical center of the that symmetrical body. Okay, next, fifth point, center of mass changes its position only under the translatory motion. That means whenever the translatory motion will take place, in such situation the center of mass of any rigid body can change as the means translatory motion, as in the translatory motion the center of mass can change time to time. Okay, sixth point, if the ith element of mass, that is del mi, is located about the point xi, yi, zi, the coordinates of the center of mass are approximately given by, the formula is x equal to 1 upon m summation I is equal to 1 to n del mi xi, or y is equal to 1 upon m summation I is equal to 1 to n del mi yi, z is equal to 1 upon m summation I is equal to 1 to n del mi zi. This already we have taken out this formula for the 2 particle system and for the n particle system. Now the condition is here, like as we make n bigger and each del mi smaller and smaller, this expression become exact. In that case we denote the sums over I by integral. Thus coordinates of the center of mass now are given by x equal to 1 upon m integration of x dm. You can see here this del m will become dm here, as we are taking m as a smaller and smaller. So in such situation this del m will become dm here, and the summation, this summation sign will change to the integration sign here. So x equal to 1 upon m integration x dm, y equal to 1 upon m integration y dm, and z equal to 1 upon m integration z dm. This way we can represent the coordinates of the center of mass. And the vector expression equivalent to these 3 scalar expression is given by r, that is equal to 1 upon m integration of r dm. If center of mass lies at the origin of the coordinate system, then obviously the r will be, which is located x, y, z equal to 0. So integration of r dm is also 0, and so that the integration of x dm ydm and zdm will be also equal to 0. Now we'll see the question. 3 particles of masses 0.2 kg, 0.3 kg and 0.4 kg are situated at the vertices A, B and C of right angle triangle ABC with angle A 90 degree, AB 2 centimeter along x-axis and BC equal to 2.5 centimeter. Find the distance of center of mass from A. So the arrangement is given here. First of all, 3 particles are there and the masses are mentioned here. Angle A is 90 degree. So we have made here angle A 90 degree. AB is written here, that AB along x-axis and which is 2 centimeter here, and it is given BC, that is 2.5 centimeter. So we have arranged here at point A the first mass 0.2 kg, this is 0.3 kg at point B, and the point C 0.4 kg mass is there. Since this is AB along x-axis, obviously AC will be on the y-axis. So this point A is the origin, that is 0, 0 coordinate here. The coordinate of B can be taken here as 2, 0 because it is x-axis. So y coordinate would be 0 and x will be 2. To find out the coordinate of this point C, we have to find out AC. So first of all, we'll find AC. To find AC, we'll just apply the Pythagoras theorem, that is BC square minus AB square, and root of this will give us AC. BC is 2.5 square minus 2 square, and this is root. So now 2.5 is 6.25 minus 2 square is 4 here. So 6.25 minus 4 will be equal to 2.25. Root of 2.25 will be 1.5. So this will be 1.5. Now we can give the coordinate of this point also, the point C, and it will be, the x coordinate is 0 here, 1.5, y coordinate is here. Now we'll see the x coordinate, that means the center of mass. We'll take out the coordinates of the center of mass. For that, we'll write here x cm, that means x coordinate of center of mass will be given by m1 x1 m2 x2 plus m3 x3 upon, here it is m1 plus m2 plus m3. Now we'll put the value here. m1 is 0.2, the x1 coordinate is 0 here, m2 is 0.3 and the x2 coordinate is 2 here, m3 is 0.4, then the coordinate is, x3 coordinate is also 0 here, upon 0.2, 0.3 plus 0.4. We'll get here, this will be 0, this will be 0, and it is 2 3s are 6, so 0.6 here, upon, this is 3 2 5 plus 4 9, this is 0.9, or we can say 6 upon 9, or we can say 3 2s are and 3 3s are. that means 2 upon 3 centimeter. So the x coordinate is 2 upon 3 centimeter. Now we'll see the y coordinate, YCM. This is M1 Y1, M2 Y2, M3 Y3 upon M1 plus M2 plus M3. Then it is equal to 0.2. The y1 coordinate is 0 here. Now 0.3, this is also 0 plus 0.4, that y3 coordinate is 1.5 here, and upon you will find 0.2, 0.3 plus 0.4. So we'll see this is 0.9, already we have calculated, and it will be 0, 0 and 15 fours are, that is, we'll see 0.6 again, 60, that is 0.6 again, and it is 2.3 centimeter. Now we have to find out the distance of center of mass from origin A. So from origin, if we have to find out, we'll see the distance of center of mass, that is in the z axis, that is equal to x cm square plus y cm square. We have to, means we know the distance formula, that is x2 minus x1 the whole square plus the y2 minus y1 the whole square, and since the x1 and y1 is the origin, so 0 0 will be there, so directly we have applied the formula here, that is x square plus y square, and it is equal to 2 upon 3 the whole square plus 2 upon 3 the whole square, that is 4 upon 9 plus 4 upon 9, or either we can take out 2 upon 3 common also, directly we can write here, this is 2 upon 3, will take out common, so here it will 1 and this will also 1, so directly we can write this as this way, or either in this way also the formula will come, that is 2 upon 3 root 2 centimeter. So the center of mass will be 2 upon 3 root 2 centimeter from the origin.